How can Africa speed up its development? By speeding up its energy transformation. Despite Africa's great potential for clean energy, only a tiny fraction of the world's renewables is installed here. The African continent is growing faster than ever, and it simply can no longer afford more investments in the dirty and fragile economy of the past. Today, we're at a turning point. The recovery plans are the once-in-history push to radically change direction. We are here to make it happen. At Res for Africa, we stand for Africa. We believe in its huge potential. We believe in its innate energy. We believe in its growth. And we believe that all it needs is an enabling environment for its full development. At Res for Africa, we care for Africa. That's why we believe that clean energy is the only way to go. Because renewables mean more affordability. Because renewables mean more jobs. Because renewables mean more value. Because renewables mean more resilience, social justice, and health. At Res for Africa, we join for Africa. A unique blend of expertise along the whole value chain of renewables, joining forces to accelerate the transition towards a sustainable and inclusive future. At Res for Africa, we innovate for Africa. We constantly look for new, improved energy solutions to provide not just clean and powerful electricity, but also cutting-edge and reliable plants, electrical grids that guarantee quality and stability through digitalization and storage. At Res for Africa, we act for Africa. We promote dialogue between governments and private players to define conscious, long-term policies, encouraging adequate investments. We share know-how with all stakeholders to promote the full development of Africa together. We train locals on the field to share our expertise and make them owners of their energy. And we never, ever stop looking for new and win-win business models made of African DNA. With a long-term green recovery strategy, we can finally build back better in Africa, ensuring universal access to energy, making its economy more resilient, and leading the whole continent straight into a sustainable era. We are Res for Africa. Our mission is to build a better future through better energy. In Africa, with Africa, for Africa.
Good morning, ladies and gentlemen, and welcome to the first webinar on digitalization of Africa. This is the first of 5 webinars we plan to broadcast to our African colleagues and friends to touch the issue of the disruptive technology riding the wave of digital revolution. Many of you already know us because we have been broadcasting every Wednesday for 3 months our training course, but welcome also to the new person. I go quickly to the broad context of the topic. Next slide, please. First of all, just reminding you who are we? We are a foundation with the several, let's say, members from the leading value chain experts in Europe, and not only in Europe. we work to accelerate the framework to allow investments there. Next slide shows also we also have rely on a bunch of projects. You see number 4 is a deep topic of today. We have these strategic initiatives ongoing to respond to the requests and needs of our African partners. And today we concentrate on innovation and digitalization, while we will inform you of the other ongoing initiatives. All of them will receive a step change in this year, 2021. Next slide shows also that we work with the regional local partners. You see, we put there only the logos of the entity with which we have a clear formal relations and with which we do share many of our projects. In the next slide, you also see the broader international partnership. It's really too many, but I can assure you we work with all of them, from United Nations and Europeans to the banks, to the non-governmental organizations, and so on, and particularly the Academia Research Center. We have with each one of them, they are on board with us to provide this acceleration of the framework for investment. Now, next slide introduce a little bit the topic of today. Digital technologies are everywhere. You see those little photos here, and on the right you see the book on the IEA. This morning on the radio I heard that even in art, in the Italian pavilion in Dubai will have a digital copy of the David of Michelangelo. It's 5 meters high. It's done through a sophisticated digitalization process. And I was assured by the professor there that nobody will see a difference at 2 meters distance. Means we're going to export even art. So that's another additional role of the digitalization. But we will concentrate next slides on a single topic, the digital transformation of the energy system. You know, many years ago, when I was a young researcher, the system was working only this way, from the power plant to the customers. And now, next slide, the new approach is that digital technology enable a multi-directional and highly integrated energy system. You see all of them interact with each other. So the consequence, let me just highlight 3 consequences. First one, the demand side management of the houses. In the next slide, you see an example. The residential sector, we can count on 1 billion households today who could worldwide provide 11 billion smart appliances, and this will absolutely, let's say, impact on the way the consumer and the customer interact with the system. The next slide shows an additional application, the smart charging of electrical vehicles. You see on the left down the transportation, and again with the smart charging instead of standard charging, you can reduce the required power in terms of a gigawatt. You see, those are general number. But again, you know, transportation, electrical mobility will be one of the main storage and flexible tools to increase electrification. And finally, the third example I bring, next slide, is the one we are more familiar with, the integration of variable renewable. You see that in 2040, with the digital flexibility, we can reduce the curtailment of solar PV and wind from 7% to 1.5%. So this is another issue that I'm sure today my colleague in the panel will certainly highlight. So next again, the topic we are discussing is why we rest for Africa. Well, we think that the innovation in this area will be a real game changer, particularly in the energy access and decarbonized electricity. We identify at the moment 3 topics: integration renewable, I showed before, connectivity, and new digital tools, which will allow the system to be more flexible, more efficient, and more also environmentally sound. Next slide shows also the aim. At this moment, at the first day, we aim to have those results. First of all, boost the adoption of innovative, low-cost digital solutions for Africa, enhance knowledge and human capacity by sharing with you our track record, our lesson learned, not only in Europe, but everywhere, in Brazil, in Thailand, in Australia. so we can make sure that we profit from each other's knowledge, support the African countries in scoping and selecting innovative solutions, and I mentioned before reliability, affordability, and sustainability, demonstrate with evidence-based analysis the benefit of solution, and finally, support the implementation of nexus-based projects like water, energy, food to showcase the potential for access to electricity and productive use. So all this is, in a nutshell, our initial program. Maybe at the end of the 5 webinar, we add some or we'll change the priority of those ones. And finally, the next slide shows the calendar. Today we are April 14th. Next webinar will be April 28th, and will be on digital transformation of energy management in Africa, solution for mini grids. At the other side of the coin, today we speak mostly about large scale. We will speak about mini grids there, and then we have in May still to be defined the electric mobility opportunity in Northern Africa, asked also by the Moroccan government, and then shaping the smart and sustainable infrastructure for the future in June, and so on. So those 5 webinars that Carlo Cecchetti and friends contributed to organize, are the beginning of a better understanding how Rest for Africa can add value to the African partner in terms of digitalization. And I think the next one is the final one. Next slide. Well, this is the dream of everybody in terms of digitalization in the system. It's a nice picture. I don't want to go in detail. I hope that also Africa as well as Europe will do quickly. And the last one is just a recall of the position paper existing. Next slide is the final one, I assure you. Next slide shows some of the papers I've been reading with Carlo to prepare this topic. All of them are on my desktop. In case you want to have a copy of them, let us know through Carlo, and we'll send you. Those are, let's say, to know more about. Those are late papers from consultants, but also from agency, IRENA, World Forum. I think all of them are there to show the issue. So thank you very much for your attention. Now, with this very sharp introduction, I pass the floor to Carlo Cecchetti, who is the owner of the project, and we will listen through him the sequence of speaker hoping to provide you a service, but also to learn from you. Carlo, the floor is yours.
Thank you. Thank you, Roberto, and good morning to everyone. Before starting with the presentation of our speaker, I would like to thank you all for the participation, and I hope we will have all of you during these 5 webinars that will come starting from April to June, July. So we will be really glad to have all of you all together. Now it's time to introduce the first guest of the day, Schneider Electric, which recently became Rest for Africa member, and it is a pleasure to have with us now Amel Chadli, Vice President and Middle East and Africa Digital Energy and Business Development, together with Amr Kandil, Business Development Expert. Amr, please, the floor is yours.
Thank you very much, Carlo. Thank you for inviting us, Roberto. It's a real pleasure and honor to be with you today to represent Schneider Electric. Next slide, please. So yes, I will be with my colleague Amr Kandil in order to present you how we are seeing connecting Africa to a brighter future. And according to us, so to connect Africa to a brighter future is by sustainability, and for sure by using digital product and solution. So next slide, please. Yeah, as of today, in fact, what we will explain to you is the sustainability purposes for Schneider. Then we will deep dive a little bit on the main challenge that Africa is facing, who are the urbanization and the climate change. And finally, we will explain how the digital and the value proposition of Schneider can contribute to face these main challenges and to participate to the respect of the SDGs. Next slide, please. Thank you. At Schneider, our purpose is to empower all to make the most of our energy and resources, bridging the progress with the sustainability for all. We call this Life is On. We are willing and we want to bring the energy to the 2 billion people that doesn't have access to energy. And at the same time, we need to be meaningful by the usage of the energy and the resources. And we want to divide the carbon emission by 2 during the following 20 years. We really believe that the access to energy is a basic human right that everyone needs to have. This is the reason why we gave us the mission to be the digital partner for sustainability and efficiency. Next slide, please. So in our daily work, we really tackle the sustainability purposes, and we are applying very hard standards in order to reduce the carbon emission in our internal footprint, but also we are helping our customers to reduce the CO2. So in 2 years and a half, we reduce it by 107 million tons, and we will continue this fight. We are also bringing a very disruptive technologies in order to participate to the reduction of the CO2, and we have some innovative solutions like the SFC-free that we are very proud about, as it's the first world switchgear powered by air and digital. We are following very cautiously our sustainable products and solutions, and we are also publishing the results in terms of sustainability, and 75% of our revenues are recognized as green premium. So in order to elevate the standard, we gave to us also the ambition to be carbon neutral in 2025. Next slide, please. We were honored to be recognized as the world's most sustainable company this year, and we want to take the sustainability to the next level by defining 6 long-term commitments for the planet. The first one, the first commitment is to act for a climate positive world, where we need to reduce drastically the carbon usage and emission. The second commitment is to be efficient with the resources in order to preserve our planet. The third one is to live up the trust in the business world and in our way of living. The fourth one is to create equal opportunities for all, and by creating a very safe environment to all employees without any differences about their origin, their beliefs, or their gender. The fifth one is to harness the power of all the generation. And finally, the sixth one is to empower the local communities. As most of you know, we are the most local global companies, and we are empowering the local communities in order to contribute to a brighter future. So in a very nutshell, the sustainability is really in our heart and very close to our strategy. We are walking the talk, and we believe that in order to bring a better world, we need to use the sustainability purpose and the digital in the innovation in order to bring the access to energy for all. Next slide, please. So in addition to our purpose about the sustainability, we have Africa, where we are present since a few decades now, and we are implemented in almost all the countries. So we have the willing to help in the resolution of the challenges that Africa are facing. And Africa are facing mainly two big challenges. The first one is the urbanization. As you know, today we have 43% of the population who are living in the cities. It represents almost 500 million people. But in 2050, the urbanized people in Africa will be about 1.4 billion people. So in order to help in this transition, we need to build infrastructure, schools, hospitals, social housing, and all infrastructures that will help to feed the new urbanization. So we will have also three mega cities, which will be Dar es Salaam, Johannesburg, and Luanda. The balance also in Africa will change, as today, in fact, Maghreb is the most urbanized region in Africa, but tomorrow West Africa will grow significantly. And for example, as of today, the fourth most urbanized countries in Africa are Nigeria, Egypt, and then we have DRC and Algeria. In 2050, the countries will change. Nigeria will remain the most urbanized country, but then DRC will be the second one, Ethiopia will be the third one, and finally Tanzania will come in the fourth places. So in order to help all these transitions and this transformation, we need to think how to provide the energy to these new cities, and how to make it accessible and sustainable, and for sure more digital. The second challenge that Africa is facing, next slide please. Yes, the second challenge that Africa is facing is the climate change. And Africa is one of the most vulnerable regions in the world to climate change for different reasons. The first one, Africa is really depending on the biodiversity for the agriculture, for the food, but also for the non-conceptive reasons like the tourism. The agriculture is also very disrupted by the climate change, and as we know, in Africa the agriculture is depending a lot from the rain, and during the last 20 years we observed the warming in the climate by 0.7 degrees in Africa. This has as consequences, in fact, less rain in the Sahel, which impact the agriculture and put more pressure on the water, but it's also increased the rain in East Africa, and again it has a negative impact in the agriculture. Finally, the climate change could also create a lot of diseases or accelerate some diseases, which will be impacting the people. So for all these reasons, in fact, we think that the impact of climate change in Africa is really important and needs to be tackled seriously, because it creates the water scarcity, it creates or increase the food insecurity, and finally it could also enhance the access to energy topic. So in order to face these two challenges, we think that the digital could be contributing to resolve the equation. So next slide, please. The good news about the digital is really spreading, and is spreading 23 times more than the electricity on the grid. So we see it like a fantastic tool to help the people to participate to the SDG. So the digital is really everywhere and can help us to face the different challenges in terms of food and housing, health and learning, in terms of optimizing the infrastructure, rebuilding the new ways of working or rethinking the mobility. So I will let the floor to my colleague Amr Al-Kandil to explain to you how the value proposition of Schneider can contribute to a brighter and more sustainable world. Amr, thank you.
Thank you, Amal. Hello again. So building on what Amal have mentioned, let me take you through some of the solutions and value proposition that we really believe they have like a good impact on Africa. Next slide, please. So the diversification of the economy away from natural resources remains one of the key challenges, which require improvement in physical infrastructure, expanding the manufacturing base of the economy, and post higher value services. Actually, Amal have mentioned and introduced the urbanization trends in Africa. I would say globally, there is a correlation between urbanization rates and the national level of human development, with higher level of urbanization generally corresponding to higher levels of human development and vice versa. In some countries, sustained economic growth over the last decades have not translated into tangible improvement in their standard, for example, of living, in particular, the poor people. One key reason for this outcome is that the urban economy has not created sufficient jobs. Besides that, growth largely occurred in sectors with little connection to poor, such as oil production. So industrialization could be the secret, and we're ready in every step of the value chain. So next, please. Starting with having smart energy, for example, that will provide more sustainable electricity system, and after that, next, please. The water will come with its water desalination, for example, which is really important for Africa nowadays, and we need to consider with all the value proposition and solution. Then will come the smart farming and irrigation that will provide and help in decision making, reducing water wastage and increasing efficiency at farms. After that, we will find another value proposition in different dimension, which is a smart manufacturing, which we really need right now to improve the profitability and increase flexibility. Then will come after that the smart food, which is the consequence and the real output that will help us to have food safety, compliance, and traceability, and it's really important in this step. After that, we will not forget the smart facility that will help to provide safe, available, efficient, and the green buildings that we really need in order to increase the profitability. And all of this at the end will be covered with the supply chain. Next, please. Supply chain or smart supply chain to reduce sourcing and logistic costs. I would like to mention that all of these solutions will help us to have like a real direct impact on the SDGs, and all of them combined together is helping in achieving the sustainable cities and communities. Next, please. Next, yes. So through the solutions I mentioned, which cover the whole value chain, we are helping to improve the sustainability, efficiency, and traceability. And this is taking into account these important 5 value propositions that will result in what we call a smart food. So what is this value proposition? The first one is environmental sustainability, which we really need in order to reduce the carbon footprint and the climate change that Amal have mentioned. Then will come the operational efficiency to remove all the wastes from your process and increase your profitability. Total cost of ownership, which is a new term that we really need to know and understand, and to know which solution that can help us to reduce the cost of the existing assets. After that, the flexibility and the brand promises to meet the customer riding demands with the right products. And at the end, the food safety for fewer or eliminating the risk linked to the food safety as well. Next, please. So in order to start with the smart energy, let's take together some outlooks. Africa energy system face an enormous challenge. The region currently has the lowest electricity generation capacity and experience the most acute forms of energy poverty in the world. Approximately 630 million people live without reliable access to electricity in Africa. We are able to power your digital transformation now for a more decentralized tomorrow through the solution that I'm going to introduce. So we need to remember that term, which is grid flexibility, which refers to how effectively the grid can respond to changes in general and demand in order to keep the overall energy system in balance. And it can be increased in several ways across the whole life cycle of electricity, from the production till the low voltage consumer side. So these ways can be through ensuring access to large amount of dispatchable energy generation that can be turned on and off quickly, shift demand to match time when the energy supplied by renewable is available. For example, demand could be shifted to times of the day when solar energy output is higher, and this is required like a smart technology. Interconnected distributed energy resources over large geographical area. This means that if the wind stops blowing in one place, or if one area gets covered by cloud, it's possible to draw from other generation areas that are experiencing sunny or windy condition, for example. So connecting the distributed energy resource is the key. And investing in smart grids that can be integrated with information communication technologies. Smart grids allow for certain non-essential appliances to be switched off or on briefly when demand of the grid is high, or for distributed generation and storage to be brought online when needed. This requires at the end a cybersecurity layer and services to protect the system data and keep it in its efficient way. Next, please. So other challenge that we are facing is the challenges in the water, and we need to consider in order to identify which solution that can face these challenges. So the first one is booming population. Rapid urbanization will come after that. Increasing per capita water requirement require from us effort to find relevant solution that can help in this. Rapidly depleting per capita water availability, aging water infrastructure and manpower, poor quality of water, which can lead to diseases and which will in return will provide like a scarcity in access to water in some places. Next, please. So through our innovative solutions and technologies and services, we help make water safe, reliable, sustainable, and efficient across the entire water cycle. Our smart water portfolio is enabling us to develop solutions that combine various offer bricks into tailored solutions to address a specific pain point of our customers within these 6 focused subsegments that you can see. This also enables us to support our customers across multiple application domains within the water cycle. Next, please. Actually, this portfolio includes automation and control, electrical distribution, critical power and cooling, facility and safety security, covering the whole life cycle, starting from water desalination, going to water treatment, wastewater treatment, water resources management as well. So actually, we are a technology provider in all areas of the water cycle. We play from floor to top floor, from shop floor to top floor. We have product solutions and services that can cover the field from field to enterprise. And this is really important, the integration between the different water resources to get a better efficiency. Next, please. So having access to water will give us the opportunity to have the better farming and better production of plants. So I would say today less than 20% land farm areas are using like a precise agriculture technology due to high cost of gathering the data. But with the digital technologies and IoT, such as connected sensors, collaborative platforms, big data, next please, and analytics, data is easy to gather in real time and in more accurate manner, allowing to increase the efficiency and productivity at farm level. It also allows to improve like risk management linked to raw material and commodities. Next, please. Such technologies can be applied to precision crop management, livestock management, farm equipment monitoring, for example, or vertical and greenhouse farming in order to produce more with a better management of existing resources. Next, please. So if we talk about smart farming solutions, we could have like outdoor farms or vertical indoor farms. At the end, technology advanced doesn't essentially mean that it's a smart system. Actually, smart systems differentiate themselves through their ability to record the data and make sense out of it. So if I'm gonna give smart a definition, I will say it's the ability to provide different services. So in order to be a smart city, you have to provide different services to your citizen to make its life more easier than the beginning. Smart farming employs hardware, IoT, and software to capture the data and give actionable insights to manage all the operation on the farm. Post, pre, and post-harvest, the data is organized, accessible all the time to provide you a better efficiency and better production of your crops. Next, please. So after that, this will require irrigation and access to energy. And now coming to irrigation and access to energy, 18% of the global population have no access to electricity, from which 84% live in rural areas. Further, there is arable land not rain-fed in some area that could be used for agriculture purpose, but without proper irrigation, it's impossible. Next, please. So clearly, there is a need for irrigation with the use of solar-powered solutions, for example, for irrigation in areas that still have no access to electricity. And we have actually a good solution, which we call water of the sun, and it's really fitting in this part. For some farmers, there is a need for viable and cost-effective solutions to enable irrigation of arable land, and we are providing this need, and we are looking forward to satisfy the farmers with what we have from solutions. Next, please. So Schneider Electric Solutions mainly aim to tackle the challenges of providing access to energy and water in specific rural areas by deploying solar water pumping systems for irrigation. For irrigation supply in off-grid areas especially, those solutions are fully automated and designed to provide water and on an affordable cost. The farmer can therefore cultivate crops in off-grid areas, lower their operation expenses compared to diesel pumps, while using a sustainable solution with zero emission of greenhouse. And this is really the benefit that they can get out of it. And this will help us in cultivated more areas and produce more food. Next, please. So, and after producing the food, this will take us to the next step, which is the smart manufacturing. I would say the current adoption of impact of Industry 4 on the African continent is still remaining low. However, it's a topic that is increasingly being acknowledged and discussed by industry leaders and policymakers, mainly because of the impact of the smart technology that can have on the socio-economic level. This is a lot, there is like a lot of interest among manufacturing to better leverage the potential for monitoring, controlling, tracking, and this is where smart manufacturing is needed through its pillars from process automation, machine and robotics for better performance, simulations and augmented reality to better understand complex process, information management and transferring data into actionable insights, in addition to the important term, which is the asset management for a maximum economic return of your assets. And it's really important. Next, please. So this will lead us to have the complete cycle smart and will take us to the smart facilities. And we really need to make sure that the production facilities and resources are consuming only the amount of energy they actually require, without any wastage, to complete the efficiency life cycle in the value chain. And we need to have all the value chain with an efficient life cycle, and help increase the profitability and release any burden of the electricity scarcity, for example. And this will help us a lot. Next, please. And the end of mind is to have a smart and safe food. And if we followed all this process, we will gain at the end the smart and safe food. And actually, it's one of the important and interesting outcomes of utilizing digital solutions is ensuring food safety, traceability as well, and compliance with the regulations, which in return is boosting the efficient utilization of food in a continent facing food availability and the quality problems. Thank you, and we are welcoming any question if you have.
Thank you very much, Amel. Thank you, Amra, for your interesting presentation. We are looking forward to see you and Schneider Electric also in the next webinar of 28th of April about mini and microgrids. Now it's time to introduce Enel Green Power, one of the founder members of RES for Africa. And today we have with us Giuseppe Serrecchia, Head of Global Power Generation Digital Hub, and Nicola Rossi, Head of Innovation of Enel Green Power. Giuseppe, Nicola, please, the floor is yours, and welcome.
Thank you very much, Carlo. I introduce myself first, then I'll leave Nicola introduce himself as well. I work in the global power generation, which is one of the business line of the Enel Group for the generation of electricity. And I supervise all the digital activities within this business line and work closely with the team of innovation, which is led by Nicola. So, Nicola, I leave to you to present yourself.
Yes, thanks, Giuseppe. Good morning, everyone. I'm Nicola Rossi. Giuseppe said I'm leading innovation in global power generation. And you know, innovation and digitalization are in many cases very much related to each other. So this is why we decided to approach this topic together with Giuseppe. So thanks a lot for inviting me. And please, Giuseppe, let's start with the presentation.
Sure. Thanks, Nicola. We have organized the presentation by giving an overview at the high level of the strategy, the digital strategy of Enel in general. So we have taken a few charts from our Capital Market Day, and then we zoom into the digital strategy within the business line where we belong, which is the power generation, and then again we zoom into our footprint in the African continent, and we will showcase some of the things that we are doing together, Nicola, which are of particular relevance in the African continent, but not only, showing to you how it is important to have also a global view of these solutions, which can fit many other places in the world and not just Africa. So if we go to the next chart, this is just to put some floor for our presentation. We know that the evolution of technology is it's at a very fast pace today, and it's transforming every industry and also the industry of the energy. So if we look at the projection, which are published by agencies like the International Energy Agency in its latest World Energy Outlook of 2020, the projection in the next couple of decades of the production of renewable, it's projected to be 4 times than it is today. Creating, of course, a huge market for everyone in this case. And at the same time, from the same report, you see that this increased share of renewable energy at the lower economic and social cost will allow a consumer to opt for a higher share of electricity consumption, projected to be 40% higher in the next couple of decades. But all this does not come for free. So there are some complexity elements that needs to be taken into account. And these require a new level of services. So we consider the coupling of battery storage with renewable capacity, this becomes key enabler of systems of flexibility, reliability. It will reduce exposure to unbalancing costs, curtailments, congestions, and also we see that fragmentation of the production, and so a distributed generation of asset that needs to be orchestrated. So utility clients also, consumers, can become producers as well. And so we see the birth of the prosumer figure, which is someone who produces and consumes as well in the system. And so this evolution of technology require the utility to become this orchestrator. So if we go to the next chart, and be at the center of this complex system. Indeed, as Roberto just introduced, the dream, this is basically the same concept that was introduced by Roberto at the beginning. And indeed, the digital, it's at the heart of all this kind of transformation, because the utility will not act only as owners or operators of assets, but also as enablers and orchestrators of service. So the system will be composed of multitudes of distributed generations, as we said, and digital platforms are key to managing this increased complexity, because with the digital, we are able to have a scale effect, improving and augmented the volumes with marginal costs close to zero, ideally, and have a higher efficiency. This, on its turn, will create value for customers, who, as we said, become also producers, not just consumers, but we will be able finally also to introduce innovation and sustainability within this scenario. And this is what we are doing actually in the last years in Enel and in Enel Green Power, with a model of innovation that Nicola will talk about. So Nicola, please.
Yes, thanks, Giuseppe. We can move to the next chart. That is just to introduce our what we call innovability model. No, innovability is a new word in neologism. That is the fusion of two words, innovation and sustainability, because we see sustainability as the final target, and we see innovation as a way to reach more sustainable business. And for sure, digitalization is a key lever to innovate, both in terms of technology and in terms of business model. These two things are very much related to each other. So if we go to the next chart, this is just to say that we decided to choose to innovate an open innovation and an ecosystemic model. Basically, today our ecosystem is based on approximately 500,000 players. And the reason for this is very simple. We need to innovate and to change the way we work very quickly, because the world around us is changing very quickly as well. And the only way to do this is to involve an ecosystem of partners, selected partners, to work with you on areas of interest for us and to innovate together. And this is exactly what we are doing. Here you see, let's say, the constellation of players we are working with today. They include industrial partners, they include startups, financial communities, suppliers, customers, our colleagues all around the world, institutions, universities, of course. And this is what has allowed us to activate more than 900 projects in the last few years, with more than 70,000 ideas received so far, through a platform, again, digitalization, that we have designed in order to manage this complexity, that is open innovability platform. It is the interface between us and the ecosystem around us that allows to cooperate with this ecosystem more effectively. If we go to the next chart, very briefly, just to introduce some figures of this process in the last few years. So we were able to scout approximately 10,000. This is just startups, so just part of the ecosystem. We were able to scout approximately 10,000 startups to activate 350 more or less a collaboration with some of them. And some of these startups were able to scale up working with us, of which 20% digital. So 20% of the startups that working with us were able to grow up and to scale industrially, the digital fraction is pretty significant. So as a summary, every 100 proposal, we scale one project that creates 3 times the invested value. This is the strength of the model. And the way we do this is through a number of what we call innovation hubs that are distributed worldwide. Today they are 10, and they are sort of antennas through which we intercept good opportunities, and we start working with the best players and the best partners for us. You see here also some figures on the investments. Our model is not to enter into the startup shares, but to buy their products and buying their products, support them to grow. And buy their products means to activate proof of concept with them as the first step. So here you see some of the figures. In the last few years, we invested more than 50 million in POC with startups. Some of them were able to scale up, generating value for us and for the startups as well. So that's more or less the model we follow.
So maybe we go to the next slide.
Go to the next chart. Yes.
So we have seen this model of innovation, and we work very closely with this model. Basically, we use it very much for scouting new solutions in the digital area. So innovation is not only about digital, but a very big share of the activities today are on digital. And in order to do this effectively, we needed to start the journey of digital transformation. So just to give you a bit of settings on how Enel did that, we started some years ago, in 2016, 2019, we laid down what we call the foundation of our digitalization. And we based it heavily on a transformation of all our software applications to the cloud. So we kicked off this massive transition and change, and we completed successfully this transformation in April 2019 with a significant impact on the performance of our business in terms of scalability, in terms of automation, in terms of efficiency. And today we start a new wave, a new phase of this transformation that we have called platformization. So we are moving toward a paradigm that in the new energy world is the usage of what we call digital platforms. In few words, this has to do with the replacement of the traditional siloed approach with a more open approach, with also a change in the organizational model that we have used so far. And this means that we are shaping a multi-layered digital architecture that connects data to the various business solutions without any friction. So this is really about removing every kind of barrier to the development of new solution. A digital platform, so it's a platform, but comes also with an operating model. And our business will support our growth by guaranteeing, in this way, scalability, growth with marginal cost, standardization of our solutions, and flexible at the same time as we need to cope with different contexts and different realities which are around the globe. And as we have a large and diversified pipeline that we integrate in many countries, different aspects of business lines, we need to address this with an array of interoperable platforms. And this journey started last year and is ongoing today. If we zoom and focus on the business line of the power generation and the Enel Green Power, going to the next slide, we see what is the ambition that we want to fulfill in the next decade and how we want to support that with a digital strategy and a digital approach. So we want to become and retain a role of super major. Our objective is to triple our total capacity to 145 gigawatt in a decade. This is an incredible growth compared with the past. And this will grow our market share of renewable from 2.5 roughly today to approximately 4% given the projection that we have available today. And that means that it's still a small share if we compare to the global installation of renewable plants. That means that there will be room for everyone. Digitalization and platformization specifically for us contribute to our sustainability goals by creating shared value together with goals of decarbonization, electrification, and our journey to a just transition. So the global business of renewable today maintains its position thanks to an operating and maintenance platform which is in place today and which is a global platform. By leveraging on a worldwide platform-based system for making business development and a platform which are building in these days that concerns the engineering and the construction. And all these segments of the value chain within the business line are connected and are part of a same platform model. But to enable this transformation and to enable this new operating model, we needed to create a digital infrastructure model on a global basis. So to find and foremost to connect assets to a central platform that will have a global blueprint. So be they control monitoring, be they analytics or things like that. And we need a framework to cope with the many different contexts in the countries tied to regulations, tied to different technology, tied to the specificity of the geography itself. So a global framework, but flexible, capable to be instantiated in the specific area. And all this comes, of course, with new risks associated because we connect assets and the cybersecurity attacks have become a reality for which we need really to protect. And this was part of the foundation that we have put in place, as I said earlier, in the first years of our build of foundation. So the infrastructural framework in the end is something general enough to allow scalability. It's flexible enough to accommodate specific needs, and it's the enabler of higher technology. So we cannot afford to have a cloud if we don't have a solid and sound connectivity solutions for that. We cannot have AI if we are not able to collect data from all our assets. So these were the kind of problems that we addressed, that we solved with some solution that we are still improving and solving for very challenging realities. If we go to the next slide, we will provide you with a basic view of where we are today. So what is our footprint in the continent? Enel Green Power started some years ago in 2014 in Africa. Today we are present with five offices in 5 countries, and there are around 200 people in South Africa, something like 40 people in Morocco, few people in Zambia, Ethiopia, and Kenya, as you can see here in the chart. There are more than 12 plants in operation with a total installed capacity of more than 1 gigawatt, mostly wind and solar technology. We have active pipeline of projects in construction in South Africa, Morocco, Ethiopia, and an active pipeline of projects under development in the countries that I mentioned, plus some more countries like Namibia, Botswana, Mozambique, and others. The availability of infrastructures, it's fundamental. So connectivity, we know, in some area of the world is not as good as in other area of the world. And this was one of the main things what we needed to address. If we wanted really to digitalize, we really need to have the ground on which to build our solutions. We see that the rate of growth of penetration of mobile in Africa, it's the fastest today globally, also because we start from a very low rate, but we have seen also that the cloud and some very big players have started to invest, and they have data center today in the cloud, and the interoperability of these data centers allows us really to put our solutions closer to where they operate. So as we said, the things that we need to address, and we will see some cases down in the presentation, where we need to enable a reliable and secure infrastructure. So connectivity, primary enable of everything, and we will see just some cases. Then a safer and more efficient executions of our processes, and we want to do that to improve and enhance the way that we work along the value chain. So more safer processes. And finally, renewables with a sustainable and circular approach, where sustainability is one of the fundamental pillars of our strategy. Let's have a look a bit at how we address the site connectivity with our model in the next slide. So we developed a strategy where we need to provide connectivity to a plant, but we want to provide connectivity to the plant not just when the plant has been built and is in operation, but early on when the plant is being constructed, because we want to use digital solutions during the construction process. And this comes by consolidating standard solutions available in the market today, defining new services with less consolidation of solutions, but mostly keeping an open radar on all the innovative solutions that we will see some of them later on. So we define this operating model for connectivity in a general way, and we applied what we call a by design approach. That means all this is part of requirements since the business development phase, and it's something that we can plug and adapt in any part of the world, but just enabling the technology or the best solution which is available there, or let's say providing a global catalog of services by relying on a network of suppliers and global contractual agreement that we have in place. We will have a look at some of the most innovative that we are trying, and here we have solutions that we call Smart Connectivity Box. If we go to the next slide, we give just a glimpse of what it means. This is an example that we have built together with the innovation, with the team of engineering, construction, and external companies and suppliers. It's a very simple concept, but very efficient. It's a rugged design that provides backhauling to the main kind of connectivities which are available. So there can be 4G, there can be radio, satellite, depending on where this solution is deployed. It's configured to connect securely to corporate networks, so it's pluggable in this way. It's modular and reusable because once it has been used for a construction of a plant, it can be reconditioned, reconfigured, and used in another plant. It's self-powered with PV, solar panel, and battery storage, so it has an autonomy, and has a wireless bridge to repeat signal to wireless antennas which are present in the campsite. So this is just to provide you an example of what we mean pluggable, modular, and what it means to have a platform where you plug something and you don't create a solution every time for every new project in some part of the world. There are other ideas like this that we are developing. So please, Nicola, maybe you can show them, because we are working together on these other solutions. Next one.
Yes.
Next slide. Yeah.
Yes, thanks, Giuseppe. Yes, this is something related more to the future, but that we are seeing as really a promising option and opportunity for us. So what we are thinking is to be an early adopter of what is called low Earth orbit satellites. So satellite connection and communication today is based on geostationary satellites that have a fixed point with respect to the ground and have an orbit that stays more or less 36,000 kilometers from the Earth. Here we are speaking of satellites that run at a height of 300 kilometers, so much closer to the Earth. And of course, they move with respect to the Earth. Okay, so this is why this solution is based on a constellation of satellites. We are observing some big players entering in this framework, and we are seeing an opportunity to use such a kind of communication technology for us in order to cover different steps of our value chain. Starting from the site surveys that today we do manually, and we just post-process the data once they have been downloaded in our computers. Construction sites where today we use satellite connectivity that is much more expensive than low Earth orbit satellites. And the plant operation where today we are using fibers and so again something that is much more complex to implement. The benefit we see from this technology is that we have a low latency due to the fact that the satellite stays closer to the Earth, and connectivity on site can be achieved with a portable and easy to install receivers, as you see in the picture, just an antenna, being able to connect with the devices on site, so supporting the activities we do on site. So here we are still in the proof of concept phase because it's a pretty recent technology, but with a great potential to be used, especially in those areas where we do not have a structured connectivity. So we have to create connectivity bubbles according to the projects we want to develop. So it could be a good opportunity for Africa as well. Let's go to the next chart. That is perhaps a crazy idea that we discovered through our Catania Innovation Lab. It's a tethered balloon that is able to create a transmitting antenna in a way that is easy to install, because you do not have a fixed structure to build, civil structure to build, and more than this, it can be moved on the site or from site to site pretty easily. So it's a transmitting antenna guaranteeing the coverage of an area around the antenna of approximately 3 kilometers. And then we have some other specific devices that are receiving antennas with Wi-Fi access point that can connect again with the tool that our operator used during the daily activities. So this receiving antenna can be distributed on the site in order to cover a wide part of the plant, but they can also be moved point by point according to, for example, the progress of the construction activities. So it's a pretty flexible infrastructure that we can adapt at different construction requirements, and it's pretty cheapy and fast to be installed. You do not require authorization, permitting, and so on. So this is why we are going to use this for this reason, because it's very flexible, and again, it's a solution to provide connectivity in our construction sites and many times in remote areas where we do not have many other options. If we go to the next chart, Okay, please, Giuseppe.
Yeah, I spent a few words on this technology, and what is really interesting is that robotization, remotization technology have been for some years in proof of concept stage. I remember more than 6 years ago, we started some really interesting use cases and proof of concept, but they remained in that stage mostly. Now the pandemic has accelerated all these developments, and the adoption has been incredible. So this is becoming a new way of working, and also a way of standardizing activities by keeping in view of regulatory issues which are present, especially for the usage of drones. So in essence, these are technologies which are enabled by that layer of connectivity, as we said earlier, and also being protected by a shield of cybersecurity measures that we need to have. In 2020, we made more than 6,000 remotized and robotized activities at the global level on almost 40% of our plants, and we are increasing our target in 2021. So we are in a scale up and adoption around the globe of all these kind of technologies. Specifically, this technology are usage of augmented reality, simply using a smartphone or smart glasses in some cases, and this allow to have some interesting cases, which is supervision by specialists remotely, which proved very, very useful during the pandemic. It proved useful for safety inspections, but as we used it, there were even more cases coming up, and today this has become a new way of working. Inspection can be done also with the usage of drones. So we fly drones over our plants to do many kind of things, from inspecting, and we will see some cases later on, inspecting the health of our assets, be they solar panels, be they wind blades, and things like that. Of course, this is not the only element that you need to have. You need to put some intelligence on top of that, and we will see some cases. So please, Nicola, if you want to show.
Yes. Very quickly, I go through some real cases and real applications of this concept. If we go to the next chart, here we see two applications. The first is on PV operation. So here the challenge is to clean without the use of water our PV panels. So what we are thinking to use are these cleaning robots, and we are also going to introduce a collaborative robot concept, because through a ground moving vehicles that are automated. These robots are shifted from one row to the other row. Okay, so this collaborative concept support us to reduce the number of robots in order to achieve the full coverage of the PV plants, and all these systems operate in an autonomous way. The other application you see in the lower part of this chart is more related to construction sites. Here you see a four-leg robot. And with this robot equipped with some payloads, we are going to accomplish to a number of tasks in construction sites, like, for example, quality control, waste tagging, fence patrolling, 3D modeling through LiDAR technologies, but also the identification of archaeological repairs or things that sometimes we have to manage while constructing our plants, or biodiversity as well. So it's something that can operate autonomously and that can support a lot the on-site activity management. If we go to the next one, This is more related to artificial intelligence, as Giuseppe was saying. Once the robot collects the data, you need to elaborate the data in order to produce usable information. So these are a couple of examples. The first is related on safety. Here we are using image recognition tool in order to verify that safety conditions are fully respected during the construction of our sites. And so we are able to identify, for example, the operators wear the helmets or the proper clothes, or even if they operate in a way that is not fully safe. And we are able to detect, early detect these events. In the lower part, you see some application of artificial intelligence that are more related to operation maintenance. So on the solar side, here we have a very big plants to monitor, and through thermal cameras and thermographic analysis, we are able to identify automatically through the overall solar field using drones the presence of defects, of malfunctioning situation, being able to substitute the PV panels that are not operating properly. And on the right side, you see an application we are testing on wind. Here, again, through the use of drone, we are collecting images on blades of the wind generators and identifying damages at an early stage in an automatic way. So through the processing of images through artificial intelligence. And we estimate that this will allow us to reduce time of our current maintenance and monitoring process by 60%. So a very big potential here to explore. Let's go to the next. I go very quick. This is another interesting topic that we are following, and this is particularly interesting because, you know, in order to guarantee the stability of a grid, of a network, you need today rotating power that is able to provide inertia to the system, that is able also to provide enough reactive power to guarantee stable voltage of the grid, and is able also to guarantee in some way to avoid harmonic distortion of the power, and so to guarantee what we call the power quality. The problem is that when you increase the quantity of renewables in the grid, the percentage of this rotating power is decreasing. And so you need to think about solutions that are able to reproduce this inertia artificially. And this is what we call grid-friendly inverters. And the final target is be able to produce this inertia synthetically, also through systems that are not rotating, like, for example, batteries, but also PV plants. Okay, so here the task is to work at the inverter level to program this inverter with advanced algorithms, able to synthetically reproduce the inertia that today is physically guaranteed by rotating machinery. And we have worked at lab scale with SINTEF and in the frame of some European projects, and now we are industrializing the solutions in cooperation with some ONMs in order to have this solution installed in real plants, especially in those areas where the grid, the network is not robust enough to integrate huge quantities of renewables. We think this is a very important solution that can support a lot of renewable growth in many countries, including Africa. If we go to the next one, I go very quickly. This is another application that we did in Africa. This is a plant in South Africa, 108 megawatt wind plant. So here the topic is more related to preservation of biodiversity. This is also a topic that has been touched in the presentation before. It is very important. So we know that when we construct a wind plant, a wind farm, we in many cases change and impact the biodiversity. But the most, let's say, serious way we impact it is causing direct fatality due to the impact between the plants and for example, the birds or the bats that cross the plant area. So in order to avoid this, we are evaluating two solutions. The first that is already ready and we are already implementing is that to introduce some deterrent action in order to avoid birds and bats to cross the plant area. And these are ultrasonic barriers that are generated through some deterrent sensors that we have installed, for example, in this specific case at Gibson Bay Wind Farm. But looking to the future, we are looking to more complex systems that are made of different sensors. So, for example, radar, to have special information about the trajectory patterns of birds, and to have also cameras that can identify the type of birds that are going to enter into the plant area. Then we cross-link this data and we take some decision about how to manage the power plant, including the possibility to stop it if there is the risk of impact within the birds and the plants itself. So it's a pretty interesting approach that is not fully available, but that we are developing and testing in different places. And Africa, for sure, is an interesting environment where to install such a kind of systems. Let's go to the next one very quickly. This is an application we did in Ethiopia, and this is an application of a BESS, of a storage, electric battery storage with a PV plant. Here the problem was to support the power quality supply for an hospital in Ethiopia, and so we integrated a 160 kilowatt PV field with a 200 kilowatt, 320 kilowatt hour BESS system with an overall management system that can be monitored and managed remotely. And the target was to mitigate the electricity interruptions for the hospital, to reduce the fuel consumption, because before this system the supply was made through a diesel engine, minimize the interferences with the hospital during the construction phase, and also to increase the overall system reliability. If we go to the next chart, we see some of the results we achieved. This installation took to a reduction of working hours of the diesel generator by 90%, a reduction of increase of self-produced power, both active and reactive, and the reduction of grid outages as well. And in the lower part, you see how the solar field is providing more or less all the energy during the day, and the battery, and you see here the blue line is entering in service to compensate grid interruptions, so guaranteeing a high quality and continuous service supply of electricity to the hospital itself. So it's an example of how BESS can improve a lot the stability of generation when you implement renewable plants and you integrate it with renewable plants. Let's go to the next one. That's the final topic I would like just to present to you, just to give you also an idea of what we are doing in the field of logistics. You know, one of the key points to be overcome when you build a wind plant mainly is the transport, because you need to adapt, and in some cases to build by scratch roads and infrastructure to be able to transport big components as blades, but also the towers of the wind turbines to the place where they have to be installed. So what we are trying to do and to experience, and we can go to the next chart, is a different way to manage this logistic, not with trucks, but with aerial transportation. So flywheels. Today there are some technologies that are still under development in an early stage of adoption, but this could be a way to be able to manage the logistic to build plants, especially in remote areas or areas difficult to access, limiting the impact on the overall ecosystem related to the construction of new roads, and also making the transportation easier, faster, and even cheaper. We are not speaking about commercially available technologies, of course. It is something that we are envisaging to be used starting from 2023, but it's something we are looking at, especially for countries where, let's say, roads and infrastructure are not always available, like, for example, Africa. So that's the last chart, and from our side, thanks a lot for your attention.
Thanks.
Thank you very much. Thank you very much, Nicola. Thank you very much, Giuseppe. It was a pleasure to have a view of Enel Green Power innovations, especially the ones regarding Africa. Now it's time to speak a little bit in deep about artificial intelligence in the energy sector. And we would like to do it with Mr. Enrico Di Martino, Project Manager of Innovation for Energy at RINA Consulting. Good morning, Enrico. Please, the floor is yours.
Yes, hello to everyone. Next slide, please. Okay, so I will very briefly present RINA. So we are an engineering and consulting company in the field of energy, research and development, transport and infrastructure, industry and marine, and we are also a certification company and Italian class society for the ships. We are about 4,000 colleagues. We have more than 200 offices in 70 countries. So I'm responsible for digital innovation project within the energy and mobility business unit. Next slide, please. So today we are talking about a solution we have developed to meet operators' need in terms of asset integrity management of wind turbines. Of course, wind energy is of an extreme importance for the transformation of energy production towards renewable sources, and we have more and more wind assets that have to be managed, and now we start having also all the wind asset that needs to be managed from a operating life point of view. So next slide, please. So we have developed a solution that is something similar to what has been mentioned by Giuseppe Serecchia and Nicola Rossi before. So we developed a solution based on artificial intelligence to automatically categorize the defects that are found on wind blades. Our solution is also able to determine the next inspection date where the blades have to be inspected again. Now, next slide, please. So starting from the classification of blade defects, we have found that operators usually use their own framework for the defect classification. So there is not at the moment an international way to categorize the defects, but each operator has its own strategy. So here we propose a classification strategy based on 5 levels, where the first category is when the blade has a good is in good shape and has no defects or very small defects, up to the 5th level, where the blade is no more operating because it's broken or has a very severe defect. So next slide, please. Okay. Now talking about the wind blade integrity management approach, we have identified 3 different levels of integrity management. So the first level is the zero maintenance approach, where blade inspection campaigns are not performed and integrity threats are identified only when they affect the turbine operability. In this case, since the defects are not early identified, usually when they are identified, they are too severe to be repaired, so we need to replace the turbine. With this strategy, of course, the operating life potential of a wind turbine is not exploited at its full potential. Then we have another approach where we perform a periodical visual inspection campaign, and each picture that is taken into the blade is analyzed by a human operator and is categorized by a human operator. Of course, this process is costly because we need people to check picture by picture, and is also prone to human errors. In this case, the blade integrity threats are identified and can be repaired. Of course, we need to wait. The human operator is able and has time to check each single picture, but of course, when a defect is identified, if it is the case, the defect is repaired. Now we have a third approach with Irrigation, the solution we have developed, where the blade inspection campaign are performed periodically with an optimized time frame, which is adjusted based on the integrity level that we have for a specific wind turbine. After that, the picture that are taken during the visual inspection campaign are automatically processed through an artificial intelligence algorithm. Then in the next slide, I will show you a little bit better the architecture of this system. Thank you. Okay, so we start from the inspection campaign that can be taken either from the ground, either using a drone. Then all the pictures that have been taken on each campaign are charged, are uploaded into a cloud storage. We consider a number of around 30 pictures for each blade. So we are talking about 90, 100 pictures for each wind turbine generator. Then, as I was saying, the pictures are charged into a cloud data storage and then are sent through a deep learning engine. This engine helps us to assign a category of integrity to each picture that is taken during the inspection campaign. After that, an automatic value is assigned to each single blade picture. Then we have the possibility to perform also a manual validation of the category that is assigned from the artificial intelligence algorithm. Because, of course, when we use artificial intelligence, we introduce an error to the system. This error is time by time decreased by the learning of the algorithm. But when we install a system, artificial intelligence system, we have, let's say, the maximum level of error that then time by time is decreased up to the level that can be reached based on the data set and on the algorithm that is used. Then our system, as I was saying, is able to define the next inspection that in our business case goes from 6 months up to 2 years, the interval between one inspection and the other. That depends on the defects that have been found. So on the overall wind turbine integrity category. Next slide, please. Okay, so here we have, let's do a little deep dive into the application layout, the front end. So here we have a table that provides, has all about the wind turbine generator that are grouped by farm. We can see the last inspection date, the next inspection date, and also the integrity status. The integrity status, when we have just the border of the blade logo, it means that the category has been assigned automatically. When we have the full color, when we have the logo that is full colored, means that the category has been also checked by an operator. Next slide, please. Okay, now this is the layout of a single blade. So within the single blade, we are able to see all the pictures that have been taken, and we also have a tool to provide comments that are like an historical information that is saved in the system, because of course the system is used for automatically categorize defects, but is also in an inspection management system. So all the data are stored within the system. They are stored by the inspection, by farm, and by the turbine. So it's very easy to retrieve data also from the past. And we also have a tool to compare pictures that I will show you later. From here, it's possible to insert the manual validation. So again, we have the same concept of having that small colored bubble that if is filled means that has been manually validated. If it's empty and we just have the board, means that the classification has been done automatically. Next slide, please. Okay, this is the fact comparison tool. So here we are able to compare different pictures on the same blade that have been taken on the same campaign, but we can also compare the evolution of a defect through the time. And from this view, we can also change the category that has been assigned, because maybe watching at the history of a defect, we are able to also to do some better consideration. Next slide, please. Okay, so this is I mean, from this slide we can see how the category can be manually assigned. As I was saying, if we see the right hand picture, we have a small circle that is empty inside and just have a border green, and then this means that the automatic classification algorithm has assigned a level 2 for this picture, and then we have the manual assigned value that in this case is category 1. So it means that the system has missed for one category, the right category, but has assigned a little bit more a little bit worse category to the picture. Of course, in our system we track all the information about the blades, the wind turbines. So we have the name, the model, the serial numbers, and all the information that needs to be collected for a system of this kind. So next slide, please. So here we have the preliminary performance of the system. Here the figure that we usually look at very carefully is the AP, which means average precision. In this case, we reached about 80% of average precision, and but from the last studies we are making, so from the last algorithm that we have developed, we are reaching about 86–87%. So we are closer and closer to the 90% threshold of average precision. So this is a very good result because the system performs pretty well. So even when we perform the manual validation, we see that usually the system assign the correct category, or it assigns a category that is very close to the right one. So it gives us a very good feeling of the integrity status of our assets. So next slide, please. No, next, okay. Thank you. So this is our final slide. So we are working also on future development. So here we see the deep learning performance improvement. So time by time, when the new pictures are uploaded into the system, we are using this picture to train again the artificial intelligence algorithm in order to improve the performance. As I was saying, we started from an 80% of average precision, and now we are going towards the 90%. So it means a significantly improve in the classification performance. We are also performing something that has the scope to use the machine learning to see all the picture, not as single pictures, but to collect all the data about a wind turbine and try to understand which is the actual integrity status of the overall turbine exploiting machine learning. So exploiting all the data we have about integrity category for the inspection picture, but we are also mixing to this data data about the life and the graphic of the turbine. So when it has been installed, where it is in the globe, so the coordinates, and also if we have data about the load, that so how long the turbine was operating, and how many repair and have been done in the past. So we are trying to put all the data, all the things that we know about a turbine into a machine learning algorithm that can give us an integrity status of the overall picture that we have for a single wind turbine. We are also integrating this system with digital twin application and with application that enables to monitor online the performance of the asset in a virtual environment. So thank you for your attention.
Thank you, Enrico. Very interesting presentation with this dive about this innovative and digitalized solution for the energy sector. Now it's my pleasure to introduce Jean-Pierre Sanchez, Business Development Director for Africa of Siemens Gamesa. Jean-Pierre, good morning, and he will tell us about energy transition in the African continent. Jean-Pierre, please, the floor is yours.
Thank you, Carlo. Thank you, Roberto. So, good morning, everyone. Well, I would like first to thank you, Rest for Africa, for giving us the opportunity to share this presentation with the audience. So we have called it innovation through integration. I mean, as a wind turbine manufacturer, of course, our main target is to sell as much as wind turbines as possible, to maintain them. But it becomes more and more evident that a more holistic approach is needed in order to enable a better integration of the renewable energies into the electrical system. And this is very much the case for Africa. So I would like to share some examples of practical solutions that have been implemented that go in that way. So next slide, please. Okay, next one. Yeah. Okay. So first of all, please let me introduce very briefly our company and our company in Africa. So as Siemens Gamesa, we have been present in Africa for more than 20 years now. We have a presence in 8 countries. It will be soon 10, as we have 2 projects under construction, one in Djibouti and another one in Ethiopia. And we have installed so far almost 3.6 gigawatts in the continent, which represent a little bit more of half of the total installed capacity in Africa. And we are maintaining around 2.5 gigawatts. Of course, a presence in the three big main markets, which are Egypt, Morocco, and South Africa. But as you see also in other markets, and I think that's very important because, well, we are aware that in the years to come, of course, these three markets that they mentioned are going to be the main ones for the wind sector. But I think it's very important for all of us and for this foundation to back, to help the emerging countries for the wind sector to be able, I mean, to profit from the resources of wind in the continent. As you all know, I mean, recently a report from the IFC have shown that the potential of the wind in Africa is huge. And of course, we are talking now that in Africa we have around 6 gigawatts installed, which is a drop in the ocean. If you compare it with the more than 16 gigawatts of potential that have been identified by IFC, and I'm talking only about sites with an average wind speed of more than 8.5 meters per second. So the resource is huge, and it's our duty to work in the sense of boosting this activity. Okay, next one, please. Yeah. Okay, so we have divided the presentation in 3 chapters. So one we call technology integration, talking about some ways of integrating the renewable energy, and in particular the wind, so through irrigation, so energy storage solutions, and also production of green hydrogen. Then another one is showing a practical example of a study of an integration of a wind farm in a weak grid. And the last chapter, some example of utilization of digitalization into the wind sector. Next, please. Yeah, okay. So talking about a hybrid solution, well, this is a pilot plant that has been commissioned in 2015 in Spain, close to Zaragoza, which is combining wind turbines with PV, with diesel and batteries, and all, of course the controlling system. So the idea behind this pilot plant was to I mean, a showcase and to simulate different load cases, to validate the way all this technology can work together, and to simulate, let's say, at a customer environment, the different loads and different situations. Next one. And this is a practical example, or let's say already an operating wind farm that has been an hybrid wind farm in India, so the first commercial hybrid plant in India, combining a 50 megawatt wind farm with a 30 megawatt PV with the control. So, well, of course, we have supplied the turbines here, so on a turnkey solution, but also the inverters for the PV and working on the whole control system. So I think it's very important to talk about hybridization and how the complementarity of different renewable energies they have, and we have to be working in lobbying the different stakeholders in order to increase the number of hybrid plants, because I think it's a very interesting solution for Africa, for instance, because it's very well adapted in cases of grids that are weaker. We are increasing the capacity factor at the connection point, so this is helping on the grid, and we are reducing the cost as well, because we are sharing some of the items with different technologies, reducing the cost of permitting, of land, and so on, and therefore lowering the cost of levelized cost of energy. Next one, please. Okay. And well, about the hybrids, I would like to mention, I mean, also an example. I mean, recently on the latest auction in South Africa of what was called the emergency auction, some of the solutions selected were hybrid, combining PV and wind. So, well, it's a way forward in this way of the integration. So now on this slide, showing some example about the storage solution. So typical solution for different issues on the integration of renewable energy. So talking about the grid stability. Yeah, I think please go forward. Yeah, more. Yeah, here, this one. Okay, so as I was saying, so those are the different cases, different issues, and how they can be solved. So about the grid stability, so using different types of batteries, avoiding the curtailment of renewable energy, either by using pumping hydro, using flow batteries, and some thermal solution as well. I'm going to mention on the next slide. And then in terms of base load of security of the energy supply, could be done also through using hydrogen as a storage solution. Next, please. Yeah. So this one is an example of a thermic storage. So we call electrical thermal energy storage technology, which is basically using surplus or an eventual surplus of renewable energy, and through a resistance of transforming it into heat, and having a store using volcanic rocks, and then discharge it to the system using the water steam. I mean, a typical steam block. So this is a plant that is already operating since 2019 in Germany, 5.4 megawatts or 130 megawatt hours with 1,000 tons of volcanic rocks, and it can store energy for around 2 weeks. And one of the particularities of this solution is that it can be implemented using existing assets. So typically, for instance, a decommissioned coal plant can be used, where you replace the furnace by the storage solution, and then you use the existing steam block in order to discharge it then into the grid. Next one, please. And then, as I mentioned before, about the production of green hydrogen. So, well, this has generated a lot of talks recently over the past months, over the past years, and of course seems to be one of the main drivers of the implementation of the renewable energies, but also about the decarbonization of the economy and the decarbonating the transport sector. So this is an example already of a pilot plant, which is combining a wind turbine with an electrolyzer. So this has been implemented. I mean, it's operating since January in Denmark. So it's a 3 megawatt wind turbine, which is directly powering a 400 kilowatts electrolyzer to produce green hydrogen. So it's an existing solution already. The fuel which is produced, the hydrogen which is produced, is used to fuel fleet of taxis in the city of Copenhagen, and it has the possibility of working in an island mode. Just I want to remind, of course, that right now only 1% of the hydrogen which is produced worldwide comes from green hydrogen, comes from renewable sources. The rest being gray or black hydrogen. And the pollution which is created for producing this hydrogen is the equivalent of the pollution of the whole country of Germany. And if we want to replace the green hydrogen, I mean the hydrogen which is now currently used by a green hydrogen, we will need around 820 gigawatts of renewable energy. And we are talking only about the current uses of hydrogen. If we talk about decarbonizing the transport, I mean the amount of hydrogen to be produced would be huge, and therefore the needs of renewables. Next, please. And this is a solution that we are working in, which is installing electrolyzer in the base of offshore wind turbines in order to have production plants of hydrogen. So instead of having an offshore wind plant that will be producing electrons, will be producing hydrogen, so directly to be loaded into vessels and being able to work off grid, therefore optimizing siting, and on the other side also having savings that will allow to reduce the cost of the hydrogen produced. Next. So this is an example that I mentioned about an integration of renewable energy, and in this case of a wind farm into a weak grid. So this is a case study that we have done for Djibouti, where we are currently constructing installing the first wind farm there. So the situation is that well, we have a country where there is no wind farms now, and the generation is mainly through diesel generators. So we have a very weak grid. There is an interconnection with Ethiopia through a 230 kV transmission line, which is giving a stability to the country and to the system, but there is disconnections from time to time. So we have been working with EDD, so the off-takers, about different solutions and analyzing, this as a case study. So we are talking about a wind farm of 17 turbines of 3.4 megawatts, with Red Sea power, with the typical scope, with the overhead lines, with the substation, foundations, and so on. And as I mentioned, so in this case study, we have come to the conclusion that in order to be able to work in this grid, in cases that is isolated to the connection with Ethiopia, so asynchronous condensers could be installed in order to add into the system, so the short circuit power needed, the inertia and the dynamic voltage control as well. Well, it was mentioned in some interventions before. So, well, it's to stress the point that even in weak grids, we can find solutions in order to integrate renewable energy. Next, please. Okay, and this is my last slide. So, just I would like to share some examples on how the digital solutions are using digitalization is applied to the wind sector. So first of all, first an application in terms of the design of the wind turbines. So creating digital twins, replicating a complete wind turbine or different elements of the wind turbine, with the aim eventually of being able to simulate completely the different cases of loads without needing at the end probably to have a real part, to have a prototype to be tested this will help to speed up the time to market for new products, and also to reduce the cost of those if you are not in the need of building a prototype to have it tested for a long period of time, and taking into account that the sector is producing more and more new models. It's going very fast. This is a solution, of course, to shorten the time to have a new product into the market. Then another use, it's in order to improve the design of the wind farms, so the design of the layout. So being used in order to better take into account the wake effect. So in the past, it was something that probably it was not so much taken into consideration, but as the size of the wind farm are growing more and more, and the size of the turbines, of course, also the wake effects have been bigger. So with the usage of big data, we are able now to simulate much better what is the effect of the wakes in the wind farms, and be able to optimize the design of the layout and optimizing, of course, the production for a wind farm. And another application also, it's to be able to tailor the towers for a given site. So being able very quickly to calculate what is the best solution in terms of tower height for a different site, and being able to have an adapted solution for every wind farm, and not only having to rely on the models that are existing on a given catalog. Also, we are using digitalization for the diagnosis of the turbines in terms of the operation and the maintenance period. Well, there's been some examples mentioned in some of the presentations before. Basically, the changes that come now is that before we had systems, accelerometers that were installed on the wind turbines that were providing data, and this data then needed to be interpreted by an operator or by a specialist in order to give solution and give a diagnosis of a problem to come, in order to anticipate the replacement of some parts of the wind turbine. So now it's possible more and more to be doing this in an automatic way, so increasing very much the speed and the reliability of this type of diagnosis. We're using also these solutions in order to improve the cybersecurity of the systems, and I'm referring mainly to the SCADA, in order to avoid intrusions and attacks that are becoming more and more frequent to the systems. Okay, and then, well, an example that was on the previous presentation, it was mentioned, so it's using robots and using drones in order to make inspection and real-time diagnosis of a situation, for instance, of the blades of the wind turbines. So that's all from my side. Thank you very much to all of you.
Thank you very much, Jean-Pierre. I have a question from you regarding the offshore green hydrogen. In which time you can foresee the next step of this technology, especially for Africa? It's something that we can expect, let's say, tomorrow, or in how many years, from your point of view, from the point of view of Siemens Gamesa?
Well, okay, so there are two aspects to be taken into consideration here, because, well, you are referring to the solution of offshore. So, of course, the question then would be, it's offshore a solution to be implemented in Africa in the short future, which is probably not the case at least on the majority of the cases. First of all, because you still have in Africa as I mentioned, and you can see on the report made by IFC that the number of sites and the potential on the onshore is huge in Africa. So therefore, it's a solution that normally can be cheaper, at least today. So it's a possibility, or let's say that, I mean, going for the onshore, I see as the main option for the years to come. Okay, and then the solution of combining the offshore with the electrolyzer to produce hydrogen. I mean, I would say that probably in a couple of years could be something that can be feasible, but we have to take into account that the main issue from my point of view here is not as much combining both the technology of wind and the electrolyzer. You have seen that this has been implemented already with an onshore turbine. The problem is that we need, I think there's a work that needs to be done in order to increase the performance of the electrolyzers, in order to lower the cost on the produced hydrogen.
Okay. Thank you very much. It was very interesting. Thank you very much, Thank you very much, Jean-Pierre. So we saw the point of view of a wind turbine producer. Now it's time for innovation and digitalization in the value chain of photovoltaic plants. And here we have Miguel Pozuelo, Key Account Manager Africa of Soltec, who will introduce us in the world of Soltec. So good morning, Miguel. Please, the floor is yours.
Thank you very much, Carlo. Good afternoon to you. Good afternoon, everyone. First of all, I would like to thank Rest for Africa for the initiative that is certainly helping the step forward towards a sustainable and inclusive development in Africa for the organization of this series of webinars that we are starting today. I think it's really interesting, and it was very insightful from the participation of the previous speakers. From Soltec, we are really proud and grateful to be part of this novel initiative. And well, as you commented, my talk today will focus on the PV role in this digital transformation, with the bifacial PV tracking as boosting the generation yield while keeping the project simplicity. So if you can change the slide, please. Okay, about myself, Miguel Pozuelo. I'm Key Account Manager dealing with the business development in Middle East and Africa markets, and I have been for the last 6 years working in the different markets of LATAM, Europe, and now in Middle East and Africa, where we are seeing the largest or the sharpest increase in PV adoption. So in the talk today, I will comment, if you can pass the slide, I will comment on the following topics. I will start giving a briefly summary about Soltec, who we are, how we stand, and what we have done and we are doing in Africa. Then I will move to explain the renewable energy context in Africa and how it relates to Soltec. I will explain why we are lucky, and to move on the solution, how PV solves the problematic that we will see in the current situation of the market. And finally, I will give you the forecast of PV adoption in Africa and what challenges we are foreseeing, or we think we have to deal with. Next slide. So about Soltec, we are a 16-year experienced company. We were founded back in 2004. We have over 1,600 employees and 15 international offices. We have over 14 gigawatts of cumulative sales. 6 of them are already under operation, with 400 megawatts in Africa, as you can see in Morocco, Kenya, Egypt, and Namibia. We have a very long track record in especially in the Americas and Europe, and we are extremely active right now in the African market. Since October last year, we are listed in the Spanish stock market with a vertical integration of the company, focused on 3 arms. The first one is Powertis, the product development branch, has over 5 gigawatt pipeline of projects, mainly in 3 markets, in Brazil, Spain, and Italy. The second arm is Soltec Industrial, that is focused on the PV equipment, mainly single-axis tracker and construction services. And finally, the third arm is focused on R&D and especially on PV technology improvement. And we will focus later in the presentation. Next slide. About our experience in Africa, as you can see in this slide, we have over 400 megawatt already installed of single-axis tracker, and we are tendering in more than 20 countries. No? So we are really active. We are seeing a very high progress. No? In the last 2-3 years, no? There are many new schemes that are incentivizing, no? the inclusion and promoting, no? The large-scale projects, large-scale PV projects in the country. In the 2 pictures on the left, you can see Benban array is in Egypt, where we supplied 350 megawatt in 2017-2018. And in the right side, you can see pictures from Morocco and Namibia project. The Morocco case is very interesting. It's the top right picture because it was the first single-axis tracker without linked rod, like single row, single-axis tracking system installed worldwide, no? And it was in Africa. And from this, it has been the solution that has been widely adopted by the industry in the coming years, and is now part of the standard technology, as we are going to comment. So talking about the context in Africa, next slide, please. Okay, we can. I'm going to mention three key aspects that come from the IRENA report, as you can see here. The first is a really interesting report. I really recommend it, not to get I think it's very insightful, not to get the picture of the continent. And I wanted to highlight these 3 aspects. No, first of all, talking about the reliability of the electricity grid, we see that it's very poor, and there is a very low access to electricity. Only 54% of the population has access to it. In the second map, we can see the penetration of renewable. We see that in the north, west, and southern Africa, there is a very low penetration of renewable, whereas in the central and east Africa, and the contribution is higher, but mostly due to the hydro technology that is covering 2/3 of the renewable capacity. So in total, we see that is 180 gigawatt of fossil fuel and nuclear generation, with only 51 gigas of renewable energy. 2/3 of them, 35 gigas, are hydro. So we have only 16 gigas of renewable energy, not accounting for the hydro. And of these is only 7.2 gigawatt installed PV, so solar energy, mainly PV, in the country. If we see in the right map, we see that the renewable generation is extremely poor when we go to the north, the western, and the southern Africa compared to the middle. And we will see later how here is where we have the best opportunity, for solar to be implemented. So if you can move to the next slide. Okay. When preparing this presentation, I was thinking, here. I was thinking about the story, so I'm going to share with you. When I joined Soltec 6 years ago, the first client, the first analysis of a project I had to do was with a Nigerian man who came and had analyzed a very critical problem that he had. And he was lacking access to the to electricity grid with continuous power outages. He was very tired of the noisy generation, diesel generation components. So he came to Soltec to find a way to solve these issues. No, he had a clear idea of integration PV with battery storage and a charge controller and a backup with some diesel generation. Taking advantage of our experience, of our knowledge, we were able to provide a solution to this problem. We designed the element, and he took everything and took in a van from the south of Spain to Nigeria. So after that first experience, I realized it should be easier than this. No, it should be easier to. There is a very specific problem. There is a good diagnosis, and the only thing that is needed is the experience, no, or the technical solution, no? And the eagerness to help on this. No? So the name of this Nigerian man was Lucky, and I feel like at Reds for Africa, no, we are this lucky. No, we are lucky because we are identifying locally a problem from Africa with African eyes, as it was shown in the corporate video at the beginning. The solution needs to be analyzed, and the problem and the solution needs to be analyzed locally, and then it's the support, no, and the technical experience and the expertise from past experience in other countries what needs to be brought together to solve the situation. So I feel we are part of the solution, but it needs to become always from local diagnosis and international experience put together. So moving to the key aspects, why solar PV is the solution, not to the problems we have seen in the previous slide. Please, next slide. There are 4 reasons that show solar PV as the key technology to respond to this problem. No, first of all is the abundance of the solar resource in the African continent. I will talk in detail later. The second is the maturity of the PV technology and how it is able to adapt very quickly to reduce the cost while providing a reliable and cost-effective solution year by year. Third of all is because it's simplicity. No, it's simple in terms of simple equipment, generally with plug-and-play solution. It's installation. It has a very easy operation, and the maintenance is quite low. And finally, the scalability. We can adapt to specific requirements, no, with a very low cost impact, depending on the scale of the installation to be done, and also it's flexible in terms to adapt to an increase in demand. So this makes it easier in parts, especially in rural areas where the demand can be increasing sharply year by year. It allows for easy scalability without a much higher investment. No? So in the next slides, I'm going to focus on the first 2 points, on the solar resource and on the PV technology. So regarding the solar resource, if you remember the map shown like a couple of slides before, we see how the parts of Africa with the highest irradiation per square meter are all the North and Western Africa and the Southern Africa. We see levels over 50% higher than what we can see in France or Germany, and double as we can see in UK. With these levels of generation, the best USD per megawatt hour have been achieved in recently, with 10.4, 12.4 USD per megawatt hour has been achieved in Saudi and UAE that has similar levels of irradiation. So what we need to do now is to find the schemes that help us to reach that cost effectiveness in the installation, taking advantage of the high resource. No? So the resource is there. We just need to find a way to make it happen. So we can move to the next slide. About the technology, I want to show in the next slide what is the standard by now in the solar PV industry, and how the industry is continuously adapting and achieving very quick steps that are optimizing cost and technology while keeping reliable. The best way to show this is with a bifacial tracking technology. No? By now, we see that most of the large-scale projects in worldwide are using bifacial PV modules mounted on single-axis tracking, and this technology was very, very early stage in 2015, when we started with an experimental bifacial PV plant with one of our clients today here. It was a 1.7 megawatt plant where the idea was to analyze how bifacial modules mounted on trackers could boost the generation. As you can see in the right, is mentioned the article from Stefano Leotta from Enel Green Power, where they show this almost 13% increase in energy generation, no? 12.8% bifacial gain of this technology. So from this moment is when it shows that that this change of technology needs to happen, and we need to be able to make it bankable, no? Be able to mature this technology. So in the next slide, you can see a diagram about how the technology works. No? What we see is that we have a very complex phenomenon in terms of bifaciality. No? It's very difficult, no, to measure in a time scale, no, in every second what is happening exactly, no, ray tracing, what's how the generation varies, how the different aspects of shading, of weather forecast, no, or, how all these components put together to have an output. However, it's a very simple equipment that makes it easier to adapt the plant itself. So the way I want to show it is that we have a very simple equipment with a very complex phenomenon, and we need to define how all these different sources of irradiation, the direct, the diffuse, and the reflected, can be measured in order to provide a bankable solution. No? In the Sankey diagram in the right of the picture, you can see the different irradiation sources we have. No? From the frontal albedo that is reflected on the soil in front of the PV modules, the tracking gain, no, that is comparing a fixed structure with a tracking system, and the beam and the diffuse. So the beam is the direct irradiation, and the diffuse that comes from the sky. Then when we add the bifacial technology, the orange part appears. No, we have another diffuse irradiation that comes from the rear side of the PV modules, and we have also the rear albedo, that is the reflected irradiation on the soil that comes in the rear side of the PV modules. So we have a solution that has bifacial PV modules together with a tracking system that is continuously varying the position, and with a string inverter that is becoming the standard solution also for large scale PV plants. No, we have passed from central inverters to string inverters that are widely used in most of the projects. No? So this solution fits perfectly with the scalability. No? It's very easy to take technology used in the 1-2 gigawatt plants in the world for distributed generation plants anywhere. So from this phenomena, we see that the equipment itself is very simple, as I was saying, PV module, the string inverter, and the bifacial PV modules, but the phenomena is what needs to be analyzed and what can be optimized. Now, how it can be optimized through collecting real-time weather and generation information and acting with artificial intelligence, as Nicola was mentioning before, being able to react on real-time situation and on the resource we have at each moment. So at Soltec, for example, in terms of the algorithm optimization for the tracking systems, we are including the diffuse irradiation monitoring, bifacial tracking, not to follow always the direct the beam irradiation, the team track, so all the shading is perfectly defined at each moment, and also the integration regarding the robotic cleaning. So, and it's an increasingly important the communication between the tracker system and the string inverter in order to optimize the solution. So there is a lot of analysis and a lot of intelligence and a lot of digital information that needs to be collected for the system. But however, this is all done like kind of in the factory. It's not something that needs to be. This knowledge is not necessary to build a plant, which is something good because it keeps the simplicity of the installation. So these are the key aspects that needs to be analyzed, in order to make this technology that was starting to appear in 2015. So if we move to the next slide, we can see how in 2017, 2018, there started to be efforts in order to define how the solar resource with bifacial technology could be defined, and how this bifacial gain that we were talking around 13% in the experimental case before, and now we can say that it's between 7 and 15%, how this can be made bankable. So in 2018, Soltec, we opened a BITEC, which is the Bifacial Tracking Evaluation Center, in order to collaborating with different entities like Black & Veatch, the National Renewable Energy Lab, RTEC, and many PV module manufacturers, in order to define under different circumstances, different pitch distances between the trackers, different PV module technology, different albedo of the soil, with white, gravel, and seasonal albedo, to define under any circumstance how the bifacial gain could be monitored. Now in 2020, we can say that over 50% of the 3 gigawatt we supplied are bifacial. So we have seen how in only 5 years, from 2015 to 2020, a technology that was barely used becomes the standard in the market, and is providing the range of 7 to 14, 15% increase in the gain. So this is what is making the PV technology cost effective, because it has the ability to get reinvented, and innovate, and come with very large cost decrease steps in a very short time. So how is this converted into the African situation, into the African market? We can go to the next slide. So we can see that in the next 5 years, since 2021 till 2025, we are expecting to see 25 gigawatt of installation. If we remember, we had 7.2 gigawatt by 2019. So we are talking about installing 4 times this, almost 4 times this figure. Most of these would be at a large utility scale, according to IHS, whereas the other 12 giga will be distributed in different sizes, no, from off-grid to small, large commercial and residential. In the long term, when we look at 2030 and 2040, according to the figures shared by IRENA and the IEA, we are talking to an increase to like 10 times, no, to 79 gigawatts according to IRENA, and 124 gigawatts according to IEA for the 2030, and for the 2040 we will be reaching in the range of 250 gigawatt to 300 gigawatt. This is almost 40 times compared to current figure of the installed capacity. No? So we see that there is a huge potential and there is a huge adoption in the PV technology thanks to this continuous competition, no, very competition. So we can move to the next slide. So what are the challenges ahead? No, from the point we are, I divided this in three points. No, first, large-scale projects. Second, in the residential projects, and finally in the standalone or small applications. So regarding the large-scale projects, the focus must be on the attraction of international investment through a transparent and well-planned tender schemes. No? This is critical in order to get competitive price and to attract the key companies of the sector into these countries. No, this is already happening. We are seeing very important tenders, no, especially in South Africa. We are seeing also in North Africa. So it's something that is already happening, but will be critical, no, in order to maximize this large-scale adoption of PV. Second is the deployment of efficient mechanisms that foster the local supply chain and the know-how transmission. We are seeing in many countries local content mechanisms that attempt to increase, you know, the competition or to feed the local industry, and there are different ways to do it. It's very important that the local content mechanism is well planned, you know? So it can help the local industry to provide steel components, to provide installation services, to provide the operation for sure, while not affecting the economics of the project. No? This is something that needs to be very accurately defined depending on each country status, and we have seen that the most successful plans on this have been the ones that have included a progressively higher local content requirement, and with a very high focus on the raw material definition, no? Starting with imported raw material and low local content requirement, and going to more aggressive scheme. And finally, large-scale projects, we think is extremely necessary to have well-defined long-term policies that allow for sustainable operation, and we avoid the starts and stops that are so that make so much damage, no, to the industry. As other renewable technologies in PV, we have a very high upfront cost that needs to be covered in the long term, and any signal of insecurity or modification can have a very high impact, no, on future investment, and will paralyze the industry, as it has happened in other markets. In terms of residential projects, we think the core is on the integration of mini grids, or helping rural locations get electrified without the need of a very robust or capillary electricity grid. The role of hybridization, as commented before, will be very important. No, the way we can integrate the solar PV with battery storage, with wind power, as Jean-Pierre was mentioning before, will be key in this transformation. And the system standardization, that allows for cost-effective solutions with easy maintenance and spares. On this sense, we have seen in the last years many variations. We are very confident that in order to reach very competitive prices for distributed generation, for mid-scale, it's very important to come up with standard solutions. In the case of Soltec, we have launched a Solar Fighter brand, which provides a combination of single-axis trackers with bifacial PV modules and string inverter that is totally defined and can be adapted to any market, and ensures that the output is well defined, and also ensures that the simplicity, and the scalability of the PV plant. Regarding the standalone projects, we see a huge potential in PV water pumping at remote locations. I had the opportunity to work in very detail on this type of project with a Soltec PV pumping installation of 350 kilowatt, and conduct an analysis of the possible integration for rural areas in Africa. And we see here that digitalization is extremely important, to monitor the irradiation input that will affect the frequency or the flow of the pump, and to match it with the minimum battery storage that provides a cost-effective solution, and together provide the optimal water need for the location. This dimensioning of the PV water pumping plant is extremely interesting, and the behavior and the successful operation will depend a lot on the digitalization, how all the factors are put together, and we make sure the pumps are working as much as possible with the lowest cost investment in terms of PV module capacity and battery storage. And finally, we see like there is a huge potential for lighting and communication infrastructure without a combination with the grid, as commented before, with a reduced capillarity of the plant. So to wrap up what we have commented in the last slide, I want to can you pass to the next slide, Fabi? Okay, perfect. Thank you very much. So just to wrap up, I would like to mention we have commented, Soltec, we have already over 400 megawatts under operation in Africa. We are tendering in over 20 countries and increasing this figure. Africa currently suffers from a low electrification rate and low renewable penetration, especially with only 7 gigas of solar, and most of the renewable is hydro. We have to change this with both PV and wind. Solar PV appears as a solution due to the high resource, especially in the northwest and southern areas of the continent. The maturity of this technology, its simplicity, scalability, and also the bankability of the current standard. That is bifacial PV tracking is the new standard we are seeing in the industry, and we have a key role. It will be very important to have real data of both the grid behavior, the weather situation, and the equipment intelligence in order to communicate to each other single axis trackers, with string inverters, with robot cleaning solutions, with other parts of the plant. And we see a forecast of PV from the current 7 gigas to between 79 and 124 by 2030, and in the range of 250 to 316 gigawatts by 2040. And that the reaction to the main challenges we have briefly commented in the previous slide will define the relatively success of this technology. So thank you very much, and that's all by my side.
Thank you very much, Miguel. Thank you very much. It was really interesting. Now we are coming to the conclusion of this interesting webinar, and I would like to give the words back to Mr. Roberto Bigotti, who will introduce our president, Mr. Salvatore Bernabei, who will make the final remarks. Roberto, please.
Thank you so much to all the speakers. We have been sharing the state of the art in several sectors of the power system. I think that we are really convinced that sharing our track record, not only but sharing also the challenges for the future deployment of a massive digitalization is being said. Now, please send your question to us, and I assure you that our speaker will respond to you later. Send also your comments on the quality and quantity of this webinar. I understand it's been very heavy, but at more than university level, but I think we are very proud to be sharing with you the top of what's going on in digitalization in generation. And also, Carlo will send to all of you the PDF of the presentation. Now, the comments from my president, Salvatore Bernabei, not only president of Rest for Africa, but also CEO of Enel Green Power, who strongly believes that innovation is everywhere in the power system. But now you can comment also, because you have seen the presentation, you can comment how do you want to proceed in the next webinar to arrive to a comprehensive program for digitalization for the system. Thank you, Salvatore. You can close the meeting after.
Thanks, Roberto. And let me, Roberto, thanks all the colleagues and the other speakers who intervened in this webinar, and that will also speak and help us to understand better how digitalization and innovation could help to increase the let's say the energization, the access to electricity also in Africa, and to make Africa a more modern and fully energized in all senses continent. I believe that innovation and the digitalization in particular are key ingredients if we want to build a more resilient continent, but also a continent that could rely on the cheapest source of electricity that as per today is renewables. In order to make this happen, we know that there are a lot of work to be done, because we have to work to make the regulatory framework helpful for the investors. We are also to work on the market rules, but we have also to work on the infrastructure. So remember also that renewables are the cheapest way of electricity, but we need also to transport and distribute electricity at the end of the day. And not all the development could be based on mini grid or off grids or in distributed electricity. This is a part of the recipe. And by the way, also the technology helps, and the innovation and the digitalization helps in this case by also helping people to get closer to the electricity itself. I will give you just an example. Some years ago, I've been working in Latin America, and we ran a project there. It was a pilot at that time where we supplied an off-grid community with the 24 hours green electricity. The system was composed by photovoltaic, wind turbine, storage systems, and there was a village network. And the issue was not making this work, but also helping people to get close with the concept of electricity, how to deal with this electricity. People at that time had no electricity. So the fact also that they need electricity and how electricity could help the development, the social, economical development was a things that they would discover because entrepreneurship and new activities started to grow day after day once they had electricity. And there was the issue that I have to buy this electricity, I have to pay for it. And imagine in this off-grid village that it was a 4,000 meters height between Chile and Bolivia, we installed also smart meters. So we didn't install at that time any smart meters in the big metropolis of Latin America, but we installed smart meters on that small village. And thanks to the technology, people who had mobile at that time, as most of people have mobile in Africa, they could buy credits of electricity and pay their bill directly. And they could know exactly how much electricity they were consuming in a different part of the day and how their new behaviors that changed when they had access to electricity, these behaviors would impact on the bill. And so they also learned how to use in the best way this rare resource because they didn't have before any electricity, and how could use in the best way this electricity for their future activities. People started, and the young people, especially the children, started to study also at night because they had the light and so on. So that was a first example that I want to remind to tell you that how technology is important also in context where technology is not spread in all the technology where people works. So renewables plus integration with grids that have to be smart grids. So technology once more and innovation in order to make this technology smart, and perhaps integration with storage. All of this infrastructure needs technology to work properly. And technology comes from innovation day after day. To transfer this business model and to find a company who will invest, you need also to work on regulation. You need to work on the market rules, but we have also to build competencies. People should be enabled. They should be empowered. Someone should also have this task to create locally the needed competencies in order to manage all this growth about electrical systems. And one of the mission of Race for Africa Foundation is to work on that, to work on the creation of these competences, of these new capabilities. We think that the energy system of tomorrow of Africa will be a system that will be fully digitalized, like in all the other countries. And as I try to resume in this short speech, this objective could be reached if we work in parallel in all different parts of the value chain: market regulations, capability building, and spread of technology. And that technology is now available. So it's not just finding the way that we could also transfer the know-how about how to manage this technology, and we can also help to make grow new proposal, new innovation from the territory, from the African continent, from the people living there. We are experiencing now the pandemic, right? We are going into a crisis, and we will come out from this crisis sooner or later. But the crisis is also an incredible opportunity for change. And in order to change, you have to think differently. And in order to think differently, you have to create something different. And creativity then is transformed into innovation when this creativity results in concrete projects, in concrete new discovery, in concrete projects, in concrete actions. So at the end, innovation is the final result of a process, and thanks to this webinar, like the one that we are holding today, and the next one, that by the way, don't miss it, the next 28th of April, where you could also observe, we will have the opportunity to look at how an innovative training program on field led by the Microgrid Academy is held. Through these events, I think that we will contribute to work on the different pieces for the final recipe of having a future Africa modern. That means also leveraging on technology and innovation to have a cheaper electricity, a reliable system, and also a more resilient system, because these kind of systems would help also Africa to be more independent from third countries and to leverage of its own natural resources to give access to electricity to people and to make and to enable a social and an economical development that we hope is very needed to reach soon in Africa. So thank you very much for your attention. And Roberto, you want to close? We don't hear you, Roberto.
Not to disturb. Okay, thank you, Salvatore, for this encouraging word. We are planning these 5 webinars, at the end of which we will substantially contribute to, as you said, to the future of Africa, building back better. So thank you. I will wait for the comments of the people attending, more to come, and then send to you. See you in 28. Please be sure you stay with us, because everything that we do is downloadable from our website. Our mission is to share and to ask your opinion. So thanks again. Carlo Cecchetti, thanks a lot for the coordination, and thanks particularly to the 5 speakers who brought different point of view. Salvatore, grazie ancora. Arrivederci. Arrivederci.
Oh, thank you to you. Bye.
Ciao, ciao. Grazie, arrivederci.